Pause this video just for a second to read the question set up and see what it's asking. In this problem, we want to find the probability of a combined event, and it turns out that this particular event of rolling a sum of either 5, 11, or 12 is a non-overlapping event. And that means that events that are non-overlapping cannot occur together. In other words, you can't roll a sum of a 5 and at the same time, with the same two dice, roll a sum of an 11. Maybe on the next roll, you could roll a different sum. That's possible, but those two events can't happen at once. Okay, so that's the first part of this question. And the next part is to find the probability of the combined event, rolling a 5, an 11, or a 12. So I found this image online, and there's several like this that give us outcomes for the sum of rolling two die. So, for instance, like if I read across this row, this is for the die that's labeled 2. And then if I read across this column, the die labeled 5, what I see is rolling a 2 and a 5 is one of many ways to get a sum of 7. But within the chart tells me all these different outcomes, and it gives me a sense of how many times those outcomes can occur. As well, I can see that there's a total of 36 possible outcomes. So what I could do is read the chart to determine what's the probability of a sum of 5, and I see 1, 2, 3, 4 times that happens. So that's 4 out of 36. And I could do something similar for 11. There's 2 times that happens out of the 36 possibilities. And there's only one way to roll a sum of 12, so that's 1 out of 36. So one other thing that we know is when we're finding probabilities of non-overlapping events, the probability that either A or B occurs is the sum of the probability of A plus the probability of B. So what that tells us is we could then take 4 over 36 and add to it 2 over 36 plus 1 over 36 to get this decimal equivalent, which is also 7 over 36. One other thing I could have done, though, again, using this chart without having to do the addition piece that you see here, is I could just determine how many 5s, 11s, and 12s are present in the chart. Well, if I count them up, there's 1, 2, 3, 4, 5, 6, 7. There's a total of 7 of those different outcomes within that chart out of the 36 total outcomes.